As the clock ticks down on two of humanity's greatest explorers, NASA's Voyager 1 and 2, we are left to ponder the mysteries and secrets that they have uncovered during their epic journey through the cosmos. But now, NASA is ending its iconic Voyager mission after 45 years. Why did NASA come up with this decision? Is there something that went wrong? Let's take a look. Launched in 1977, these uncrewed space probes have boldly gone where no spacecraft has gone before, venturing past all of the outer planets and transforming our understanding of the solar system. But now, after nearly 45 years, the Voyagers are entering the final stretch of their interstellar journey, with NASA slowly shutting down their systems. After an incredible voyage spanning over 4.5 decades, the Voyager spacecraft find themselves facing a new challenge: a dwindling power supply. The power levels of these twin probes have been gradually reducing over the course of the years, with the rate of decline being approximately 4 watts per year. As a direct consequence of this, our capacity to interact with these far-off explorers is rapidly approaching its bittersweet finale. It's a poignant moment that marks the conclusion of this historic mission, and we bid farewell to these remarkable spacecraft. To extend the life of the Voyager probes, NASA made the decision to switch off some of their instruments over time. The original complement of 10 scientific instruments that each probe carried has been reduced, leaving Voyager 2 with only 5 instruments currently in working condition, while Voyager 1 has just 4. Nevertheless, NASA intends to keep in touch with the Voyagers as they continue their incredible journeys through space by turning off additional working systems this year. The hope is to maintain contact with these pioneering spacecrafts until at least 2030, NASA ending its iconic Voyager mission. After 45 years, might be something that is disappointing for the space community. The interstellar probes we know today hold the distinction of being the farthest man-made objects in space. However, their remarkable journey began with a challenging start. During the late 1970s and early 1980s, a celestial event unfolded, a rare alignment of the 4 magnificent worlds: Jupiter, Saturn, Uranus, and Neptune. It was as if these planets were shining like pearls on a celestial necklace, forming a long arc alongside Earth. This cosmic alignment occurs only once every 176 years, presenting a golden opportunity to launch a spacecraft and explore the outer planets. This alignment held the promise of granting a significant boost in speed to any spacecraft passing by these giant planets. By taking advantage of their gravitational pull, the flight time from Earth to Neptune could be drastically reduced from 30 years to just 12 years if the spacecraft was launched during the mid-1970s. Everything looked like it was about to fall into place for NASA to start an ambitious mission known as the Grand Tour. This plan called for the organization to deploy a total of 5 probes to explore the 4 big planets, and even Pluto. In spite of how magnificent the concept was, there was a significant financial cost associated with it. Congress, mindful of the expenses, decided not to fund the full-scale Grand Tour project. Instead, they approved a scaled-down version initially known as Mariner Jupiter Saturn 1977, or MJS-77. This modified mission aimed to send 2 spacecraft to explore only 2 of the planets. Nevertheless, NASA's engineers remained optimistic. They crafted robust vehicles capable of enduring the challenges of a much longer expedition. In addition, once the twin probes had proven their worth, the researchers hoped that their planned trajectory would be extended to cover Uranus, Neptune, and even further into the solar system. Both the Voyager 1 and the Voyager 2 spacecraft were sent into orbit during the summer of 1977, just 15 days apart from one another. Initially slated for a 4-year mission, these 2 identical probes defied expectations and embarked on an extraordinary journey. And as the old proverb goes, the rest is history. In March of 1979, Voyager 1 was the first spacecraft to arrive at Jupiter. In July of the same year, Voyager 2, which took a different route, became the second spacecraft to do so. Over 33,000 photographs of Jupiter and its satellites were taken by the Voyager spacecraft when they were in orbit around the planet. Io, the 3rd largest moon of Jupiter, was the subject of some of the most jaw-dropping photographs taken by the spacecrafts. These photographs were among the many magnificent shots obtained by the spacecrafts. Its brilliant hues came as a complete and utter surprise, especially given that, at the time, all we knew about on Earth were volcanoes. Coming across a moon with 10 times the volcanic activity of Earth was an astonishing discovery. After thoroughly exploring the Jovian system, the Voyagers bid Jupiter farewell and zoomed off to Saturn. Voyager 1 hurtled through Saturn's rings, soaring past Titan and heading north out of the plane of the planets. Meanwhile, Voyager 2 continued to venture on, journeying to explore Uranus and Neptune. In 1986, Voyager 2 found 10 new moons around Uranus, adding the planet to the ever-growing list of ringed worlds. Once the 4-year grand tour was over, NASA had planned to switch off the cameras on both spacecraft. If they had gone through with this plan, the images taken by Voyager 2 of Neptune and its moons would have been the last pictures the Voyagers took. But then, Carl Sagan made a special request. He convinced officials to have Voyager 1 capture one last series of images and transmit them back to Earth, giving us a first-ever portrait of our solar system as seen from the outside. So, on February 14, 1990, at a distance of 4 billion miles, Voyager 1's cameras were aimed back toward us. The spacecraft snapped roughly 60 images of the Sun and planets, including a snapshot of Earth that later became famous as the pale blue dot. This image portrays our planet as a tiny speck against a beam of magnificent light, showcasing our insignificance on the cosmic scale. After capturing this iconic portrait, the Voyagers began their never-ending voyage into the great unknown. On December 16, 2004, an exciting announcement was made by scientists. Voyager 1 had relayed remarkable data, revealing intense values for the magnetic field at a staggering distance of 94 astronomical units. This crucial finding indicated that the spacecraft had reached the termination shock, marking its entry into the heliosheath. At this point, the solar wind experiences a sudden slowdown, becoming denser and hotter. It was a significant milestone in Voyager 1's journey. Then, on August 25, 2012, a groundbreaking moment occurred. Voyager 1 became the first spacecraft ever to cross the threshold, leaving behind the heliosphere and venturing into the realm of interstellar space. This extraordinary achievement added another feather to Voyager 1's illustrious cap. It showcased humanity's ability to explore and push the boundaries of our cosmic neighborhood. Following in its twin's footsteps, Voyager 2 joined the Interstellar Club in December 2018. NASA joyfully announced that Voyager 2 had also made its way beyond the heliosphere, further expanding our reach into the vastness of interstellar space. The Voyager's accomplishments stand as a testament to human ingenuity and determination. Today, these intrepid spacecraft hold the record for traveling the farthest and enduring the longest among all the man-made objects in history. They have ventured so far into the unknown that it takes a radio signal, traveling at the speed of light, nearly 22 hours to reach Voyager 1, and a little over 18 hours to catch up with Voyager 2. Each passing day sees them moving another 3 to 4 light seconds away from us, illustrating the vastness of their journey. Yet, despite the immense distances, the Voyager twins remain active and resilient. They faithfully transmit data back to Earth every day, even from the farthest reaches beyond the known planets of our solar system. Their ongoing mission continues to expand our understanding of the cosmos, reminding us of the boundless wonders that lie beyond our home planet. The Voyager spacecrafts are incredible feats of engineering and exploration. Unlike modern spacecraft, which rely on complex software and microprocessors to operate, almost everything aboard the Voyagers is hardwired. Despite their simplicity, these spacecrafts have traveled farther and lasted longer than any others in history. They're powered by a device that converts heat from plutonium's radioactive decay into electricity. But as temperatures drop, keeping their instruments functioning becomes increasingly challenging. Still, the Voyagers continue to send data back to Earth every day, even from beyond the solar system's most distant known planets. One instrument, the cosmic ray detector, had its heater turned off 2 years ago, and everyone expected it to stop working, yet it continues to operate. The mission engineers are now considering turning off the magnetometer and plasma science instrument to conserve power and extend the missions into the 2030s. Even if the Voyagers eventually go silent, they will continue their journeys through the cosmos, possibly passing near other stars and even circling the galaxy for millions of years. If you're enjoying this video so far, don't forget to like and subscribe to our channel for more fascinating stories. Perhaps the most intriguing aspect of the Voyager missions is the golden records they carry, intended to convey images and sounds from our world to any possible extraterrestrial civilizations that may come across them. From the sounds of crickets and falling rain to images of children and dancers, The golden records give a glimpse of our planet's diversity and culture. All in all, the Voyager missions have been wildly successful, surpassing expectations for their original 4-year lifespan. However, the Voyager's journey will eventually come to an end, and they will be lost in the vastness of space. Do you think the Voyager missions are the most successful in history? It will be like losing a limb when the Voyagers stop sending back data. There is no substitute for actually being there, and telescopes can only show us so much. When they're gone, who will follow? Click on the video links on your screens to access our other videos on space exploration.